All right, enough with vocabulary. Let's talk about the first derivative test. So what you do is you find the critical points first. Remember, the critical points are when the derivative is 0 or undefined. Then you need to find the sign, meaning positive or negative, of the derivative to the left and the right of the critical point. Now, if you go from increasing plus, right, that means derivative is positive, means you're increasing, to on the right side of your critical point, you are decreasing. And remember, right here at your critical point, you have a slope of 0. Then what do you have? You have a local or a relative maximum. And it could be an absolute, but we'll deal with that in another video. Okay, what if we go from decreasing to a slope of 0 to increasing? Well, that would be a minimum. And what if you go from, say, plus to plus? Well, that would be something like increasing to increasing. That would actually be a point of inflection, when we haven't talked about that yet, but there's no local or relative min or max. What if it went from minus to minus? Well, that would be decreasing to maybe decreasing. These are both decreasing to decreasing, but there's no local or relative min or max there. So you have to have a change. Okay, we're going to do a full problem here. So find all the relative local extrema of f of x equals x cubed minus 6x squared plus 1 on minus 1 comma 6. So this is our domain, right? We're only going from an x value of minus 1 to an x value of 6. Okay, so first thing we're going to do is we're going to take the derivative. So we've got f prime of x is going to be equal to a 3x squared minus 12x. That's it. Is there any place where that is undefined? No. But is there a place where we could set that equal to 0 and solve? Well, sure. So let's set that equal to 0. I'm going to pull out a 3x, and I'm going to be left with an x minus 4. Okay, now where are the solutions to when we set this equal to 0? Well, clearly, here's a solution here. If x equals 0, then 3 times 0 is 0, and then we've got 0 as our answer there. What about here? Well, that would be an x equals 4, because 4 minus 4 is 0. So these are our critical points. Again, like I said, on a final or on a quiz, you might see me say, hey, find the critical points. All right, what we're going to do next is we are going to set up our traditional f prime of x. So we've got our f prime of x like here, and then we're going to say what's happening with f of x. Okay, so here we're going to put our lower value, minus 1, right here. Minus 1. Okay, and then we're going to have 6 over here. I'm going to go a different color. You guys, I'm feeling funky with my colors. So we've got our minus 1, our 6, that's coming from here. And then I've got to put it in order. So I've got a 0 and then a 4. So this goes from the lowest, minus 1, 0, 4, 6. See how I've gone in order. Okay, what I need to do next is plug in a value into the derivative. So what's in between minus 1 and 0? Well, that's going to be something like x equals negative 0.5. Okay, what's in between 0 and 4? Ugh. Let's go with x equals 2. What's in between 4 and 6? We'll go with x equals 5. Now, what we need to do is plug these x values into the derivative. So I need to take this negative 0.5 and put it in for x here and here. And then that will give me an answer. I'm going to pause this video, find those values, and come right back. All right, I'm back. So what I did was I just plugged those x values into the derivative. For the first one here, when I plugged in a negative 0.5 into the derivative, I got I hate it when it does that, a 6.75, which is a positive. So I'm going to put a plus here. But when I plugged in 2 into the derivative, I got a negative 12, so I'm going to put a minus here. And then for x equals 5, I plugged that into the derivative, and I got 15, which is a positive. So folks, make sure you're plugging into the derivative. All right, well, what's happening here? Well, we are going from increasing, right? So this is going from increasing to a slope of 0 to decreasing and then to increasing. And it, it may not look like what my picture is, but see how when I have a positive, make sure you see that I'm going up, I'm increasing. When I have a negative, my slope is decreasing. When I have a positive, I am increasing. Okay, so let's go ahead and find our local mins and our local maxes. All right, so we've got the point 0, comma something. We haven't found out what that is yet. What is that 0, comma something? Well, that's going to be a local max. And that's because it's going from increasing to decreasing. And then we have our point 4, comma something, and I don't know what that something is yet, and that's going to be a local min. It could be an absolute, but we're just not sure yet. We haven't done that yet. And then don't forget about your endpoints here. This actually is right here. Think about it as being the end. This would be a local min as well, because on this side it is the lowest point in that general area. So at -1, we also have a local min. And then right here to 6, that would be a local max. Now, how do I find this value right here? Listen carefully. You have to plug this x value right here into the original function. Okay, that will give you the coordinate on your graph. Okay, here, in this right here, you're plugging into your derivative, but when you're getting your coordinate, you're plugging into the original function. So for example, I'm going to plug in 0 here, 0 here, and you can see that that's going to give me 1. All right, I'm going to pause this video and I'm going to plug in the rest to save time. Be back. All right, I'm back, and you can see that my local mins right here end up being quite low, and my local maxes were at 1. Kind of interesting. So I have found all my local mins and all my local maxes. It's possible here that I've listed also some absolute mins and maxes, but we don't know that yet. I'll teach you in another video. All right, here's another problem. You might want to pause this, try it on your own, and see if you can do this. All right, first step is going to be to find f prime of x, which is going to be 3x squared plus 6x. Okay, I'm going to factor out a 3x, and that gives me x plus 2. So my critical points, if I set this equal to 0, are going to be an x equals 0 from that, and a x equals -2 from that. Okay, so now I'm going to set up my first derivative test. My lowest value for x is going to be a -4. My highest is going to be a 1. Then next up is my 0. And then I'm going to put in, oops, just kidding actually, because a -2 should go first, because -4, then -2, then 0. You got to put this in order. All right. All right, so now remember my f prime of x is what I'm plugging into. So here I'm going to try to plug in something in the middle. Let's try x equals -3. Here in the middle is x equals -1. Here x equals 0.5. Where am I plugging those values in? I'm plugging into the derivative. Okay? All right, I'm going to pause this video, come right back with those answers. All right, I'm back. So for the first one, when I plugged in a -3, okay, I got the derivative was 9, so I have a positive for the f prime of x. Then I got a -3 for the derivative there, so that is negative, and then f prime of x is 3.75, so I've got positive. So what is my f of x function doing? So here's my f of x. What's happening to that? Well, it says it's going increasing to a slope of 0, to decreasing to a slope of 0, to increasing. All right. So we have a few local mins and maxes. As always, and maybe I need to emphasize this more, you've got to include your endpoints. So we've got -4, we've got 1, we're going to have minus 2, and we are going to have 0. Now, folks, keep in mind, sometimes it doesn't go plus minus or minus plus. Sometimes it just goes plus plus, and something like that, you actually don't have a minimum or a maximum there. All right, next thing that we're going to do is determine if these are mins or maxes. So at -4 right here, you see how it is a local min. Okay, at 1 here, that is a local max. At -2, that looks like it is a local max. And at 0, right here, we have a local min. Okay, next thing we do is we take this value right here, and where do you plug it into? You plug it into the original function because you're trying to get a coordinate on the graph. All right, let me come back and do that. All right, I'm back. All right, there it is, right there. All right, folks, that's it for the first derivative test. I'm going to come back and talk about increasing and decreasing in the next video.